Start, ma'am.
Good morning, everyone. In the previous class, we discussed some problems in the exercise. Now, in today's class, the first problem is in the Cartesian plane, O is the origin of the coordinate axis. A person starts at O and walks a distance of 3 units in the northeast direction and reaches the point P. From P, he walks 4 units of distance parallel to northwest direction and reaches the point Q. Then express the vector OQ in terms of I and J. Observe that the angle XOP is 45 degrees. The question is, they give a Cartesian plane with the O as the origin. So a person starts at O and he walks a distance of 3 units in the northwest direction. So first of all, take Cartesian plane. Cartesian plane, which is nothing but coordinate system. It takes an y-axis, O as origin, x dash axis, y and y dash axis. So which is nothing but north direction, south, east, west. North direction, south direction, east direction and west direction. So here, see, person starts at O. And walks a distance of 3 units in northwest direction. Northwest direction is this one. So this is northwest direction. So person starts at O and he walks in the direction of northwest and reaches a point P. The distance is 3 units. Person starts at O and walks in the direction of northwest, reaches point P. So the distance in between O and P is nothing but 3 units. Then after, from P, he walks 4 units of distance parallel to northwest direction. He starts at P again and walks in the direction of parallel to northwest. This is northwest direction. He walks parallel to this direction. That means in this way. He walks parallel to northwest means in this direction and reaches the point Q. And the distance in between these two is 4 units. Then we have to find OQ in terms of I and J. See the problem once again. They give a Cartesian plane with O as origin. So this is the north and this is the south, east and west directions. So a person starts at O and walks a distance of 3 units in the direction of northeast and reaches the point P. Means he starts at this place and walks in this direction. It is northeast direction and reaches the point P, which is the distance at 3 units. And then after, he again starts his walking at P and walks in the direction which is parallel to northwest. This is northwest and this is parallel to northwest direction and reaches the point Q, which is at a distance of 4 from P. This is the information given in the problem, and by using this information we have to find OQ. We have to express OQ in terms of I and J. That means we have to find the vector OQ. So let's see, and also the given the angle XOP. The angle XOP is 45 degrees. They given that angle XOP is 45 degrees. Let's draw a parallel line which is parallel to the x-axis at P. Draw a parallel at P which is parallel to the x-axis, which is nothing but PR. And we know if this is 45, then this is also 45 degrees. If this angle is 45, then this is also 45 and here also 45. And this is perpendicular means this is 90 degrees. This is 90. Then 90 plus 45. That means this whole angle, this whole will becomes what? 135 degrees. 135 degrees. That means the angle RPQ. Angle RPQ is nothing but 135 degrees. So let's see. The first of all, the given information is what is given? They given a Cartesian plane with O as origin. Given a Cartesian plane with O as origin. With O as origin. And also given a person starts at O, walks at a distance of 3 units means they give OP distance. Also given person walks in the direction of north to east from O. That implies OP is give 3 units. A person walks in the direction of northeast from O. That implies the distance from O to P is 3 units. To give the distance from O to P. And also given an angle XOP is equals to 45 degrees. Angle XOP is equals to 45 degrees. By using these two, OP is nothing but the distance between O and P. Means OP vector, magnitude of the OP vector is given, and also the angle made by this vector with the positive axis is given. By using these two values, we can find P vector. We can find P vector. How means when we draw a perpendicular line from P to the x-axis, if we get the point P, then we can write the vector form of that point. If we have the point P, x, y, then we get the vector form, which is xi plus yj. So to get the point, we have to find this distance and this distance, right? If this distance is x and this distance is y, then the point will become x comma y. So to find this and this, we can use this angle and this distance, which is nothing but a right angle triangle. In right angle triangle, by using this angle and hypotenuse, we can find the two sides. So it is nothing but from triangle O, let this has a triangle OAP. From triangle OAP, cos theta is equals to OA by 3, right? OA by 3. Let us assume this has x comma y, then we can find which is nothing but x by 3. This is nothing but the distance. Magnitude of the vector OP. Magnitude of the vector OP is indicated by R. That means we get from this the value of x as or cos theta. The value of x as or cos theta. Similarly, by using sin theta is nothing but this value by this, which is nothing but if we treat t as x comma y, this distance is y. Is y by r. From this we get the value of y as r sin theta. If the vector OP makes an angle 45 degrees with the positive x-axis and we know the magnitude of this vector, then by using these two values we can find the values of x and y of this point. From which is nothing but right angle triangle, then we get cos theta is equals to x by r and sin theta is equals to y by r. Then x is equals to r cos theta and y is equals to r sin theta. That means the point P will become what? R cos theta comma r sin theta. P will become r cos theta comma r sin theta, where r is the magnitude of this vector. R is the magnitude of this vector and the The theta is the angle made by this vector with the positive axis. So therefore, from figure, we get OP vector. If P is x comma y, then the vector OP is what? Xi plus yz, because this is a 2D dimension. If in 3-dimensional, then we get x comma y comma z, the vector will become xi plus yz plus z. But in 2-dimensional, we get x comma y, that means the vector will become xi plus yz. And here the value of x is r cos theta and the value of y is r sin theta. Substitute those values. So OP is nothing but xi plus yj, which is equals to the value of x is r cos theta I plus the value of y is r sin theta z. R sin theta z. Substitute the value of r and also the angle. That implies OP is equal to r is nothing but 3 units. 3 into cos 45 degrees I plus 3 into sin 45 degrees z. Cos 45 and sin 45 both are 1 by root 2. That implies OP will become 3 by root 2I plus 3 by root 2j. This is the vector OP. This is the vector OP. Now here what we done here? We draw a parallel line to the x-axis from P. So write that. Let PR be the parallel line to the x-axis. Then the angle RPQ will become 135 degrees. Because if this is 45, then this is also 45, and these two are perpendicular, means the angle between those two is 90. So 90 plus 45 will become, the total angle will become 135 degrees. So the angle RPQ is 135 degrees. 135 degrees. Where Q, what is Q? First of all, write about Q plus. First of all, you have to write about the Q. And person walks from P to Q in the direction parallel to northwest. That implies the distance in between PQ will become what? 4 units. The distance between PQ is 4 units. And the angle in between RPQ. The angle RPQ will become 135 degrees. 135 degrees. See this is just simple like when the coordinate system is shifted to this system. Just like when origin is shifted to some other point P in the translation of axis, when we shifted origin from 0, 0 to some other point P, then we get a new system. So here also, which is just like a new system, means this is the new x-axis. That means this is the new origin. So if the vector OP makes an angle 45 with x-axis and is at a distance of 3 from origin, then we get OP vector simply here. Similarly, if this is a new system, then this will become the new origin and this will become the new positive x-axis. And to find a vector PQ, what is enough to find vector PQ? The magnitude of the vector and the angle made by this vector with the positive axis, right? Here, to find a vector OP, what we need, by using just the magnitude of that vector and the angle made by that vector with the positive axis, we can find the vector OP simply. So similarly, here also we have the magnitude of PQ vector and the angle made by PQ with the positive axis have this. This is nothing but 130. So by using those two values, we can find the vector PQ. Simply, similarly, like this. So that implies the vector PQ will become what? R cos theta plus R sin theta. R cos theta I plus R sin theta j only. But in this, the R is nothing but magnitude of this vector and the theta is nothing but the angle made by this with the positive side. So let us indicate this by theta 1. This by R1. Because for no confusion. Because here we are indicating R and theta. So that's why here R1 and theta. So the vector PQ is equal to R1 cos theta 1 I plus R1 sin theta 1 j. And here the value of R1 is 4 and the value of theta 1 is 135. So substitute those two values, then we get the vector PQ. So that implies the vector PQ is equals to 4 cos 135 degrees I plus 4, those are vectors. 4 sin 135 degrees j. R1 is 4, theta 1 is 135. And 135 is in the second coordinate, and in the second coordinate sin is positive and cos is negative. So that's why we get the value of sin 135. 135 means 180 minus 45 means in the second coordinate. So the value is sin 45. And here cos 180 minus 45 means minus cos 45. So that's why here we get minus and here we get positive. So that implies the vector PQ is equal to minus 4 by root 2I plus 4 by root 2j. So we get what? Vector OP and similarly vector PQR we get by using the given information. But we have to find OQ. We have to find vector OQ. So by using these two vectors we can find simply OQ. How means PQ is nothing but the position vector of Q minus position vector of P. That means the value of PQ is OQ minus OP. OQ minus OP, which is equal to minus 4 by root 2I plus 4 by root 2j. And substitute the vector OP and transform this to this one. Then we get the vector OQ. OQ is equal to minus 4 by root 2I plus 4 by root 2j, and this will become positive, and the value of OP is 3 by root 2I plus 3 by root 2j. From 1. Since from 1 substitute the value of OP, then we get the value of OQ. Then OQ vector is equals to minus 4 by root 3I plus 3 by root 2I. Means minus 1 by root 2I plus j. 4 by root 2j, 3 by root 2j means 7 by root 2j. The question is express OQ in terms of I and j. So here we get OQ in terms of I and j. I and j means find vector equation. So here the vector equation of OQ is minus 1 by root 2I plus 7 by root 2j. Let's see once again I will explain this problem. They give a Cartesian plane with O as origin. They give Cartesian plane with O as origin and a person starts at O and walks in the direction of north to east, reaches the point P, which is at a distance of 3 from O. He walks his distance here and walks in this direction and reaches point P, which is at a distance of 3 from origin. And then after he walks again from P and walks in the direction parallel to north to west, means in this direction, and reaches point Q, which is at a distance 4 from P. Means he walks 4 units distance from P in north to west direction. And also the given the angle XOP is 45. By using this information, we have to find the vector OQ. Express OQ vector in the terms of I and J. Means we have to find vector OQ. So let P OP is a vector which has a magnitude as 3 units and which makes an angle 45 with the positive x-axis. When we draw a perpendicular line from P to the x-axis, which meets at A. So the triangle OAP is nothing but a right angle triangle. Then from right angle triangle, we have cos theta is equals to x by r. If this as x, this as y. If this treated as x, if this treated as y, then the value of cos theta is x by r. From this, the value of x is r cos theta, and sin theta is y by r. That implies y is equals to r sin theta. So we get the point P as r cos theta, r sin theta, where r is the magnitude of that vector and theta is the angle made by this vector with the positive axis. So therefore, the vector OP is equals to, if P is x comma y, if P is the point x comma y, then the vector will become xi plus yj. I already explained the component form of the vector. So the value of x is r cos theta and value of y is r sin theta. Substitute the value of r and theta. That r is the magnitude of the vector and theta is the angle made by that vector with the positive x-axis. By substituting those two values, we get the vector OP, which is treated as equation 1. And then after, if the cursor walks from P to Q in the direction which is parallel to the north to west and reaches the point Q, which is distance 4 units. That means PQ is 4. If this angle is 45, then when we extend this vector, that makes an angle 45 with the line which is parallel to OX. If this is 45, then this is also 45, and these two are perpendicular, so the total angle will become 135 degrees. So to find the PQ, here we have the magnitude of PQ and the angle made by this with the line which is parallel to X. Here to get the OP vector, what we need, what are the information is enough means if we have the magnitude and the angle, then we find vector easily. So similarly, here also, if this is the new system, then this is the new origin. Here we have the magnitude of the vector and the angle made with the new positive axis. So those information is enough to find the vector PQ. So similarly, how we find OP? So similarly, we can find PQ also. So PQ is also to become what? R cos theta I plus R sin theta j only. But here we are indicating with R1 and theta 1 because we are R theta are close. So that's why R1 cos theta 1 I plus R1 sin theta 1 j. The value of R1 is nothing but magnitude of the vector PQ. And the magnitude of the vector PQ is 4 and the angle made by it is 135. By substituting those two values, we get the vector PQ. But we have to find the vector OQ. PQ is nothing but position vector of Q minus position vector of P. So OQ minus OP. But transfer this to this side, we get positive and substitute the value of OP. Then we get the vector OQ in terms of I and J. That's it. Now the next problem. The point E divides the segment PQ internally in the ratio 1:2 and R is any point not on the line PQ. If F is a point on QR such that QF is to FR is equals to 2:1. Then show that EF is parallel to PR. EF is parallel to PR. See, the problem is to give a point. The point E divides the segment PQ internally in the ratio 1:2. So take a segment PQ. Segment PQ is there and the point E divides PQ in the ratio 1:2. The point E divides this in the ratio 1:2 internally. And R is any point not on the line PQ. That means PQR are not collinear. Because R is not on the line PQ. That means maybe here is there. Let R is here, not on the line. If F is a point on QR, F is a point on QR such that QF is to FR is 2:1. QF is to FR is 2:1. F is a point on QR line which divides QR in the ratio 2:1. Then show that EF is parallel to PR. We have to prove EF and PR both are parallel to each other. So first of all, given PQ is a segment which is divided by E in the ratio 1:2 internally. PQ is a segment which is divided by E in the ratio 1:2 internally. Then we get the position vector of E simply. Let O is the origin, then we get the position vector of E by using the section formula. So let O be the origin. Then position vector of E, that means OE. Position vector of A is indicated by OE. Then OE is equal to what? MB plus MA by M plus N. Formula is MB plus MA by M plus N, where M and N are 1, 2. M is 1, N is 2. And the position vector of P is treated as P, small p, and position vector of Q is treated as small q. Let us assume. Let O be the origin, that implies OP is equal to P and OQ is equal to Q and OR is equal to R. Let O be the origin, then treat O position vector of P as P and position vector of Q as Q and position vector of R as R. So by using these values and Mn, we can find the position vector of E, which is nothing but M into position vector of Q plus N into position vector of P by M plus N. So we get OQ as what? 1 into Q plus 2 into P. 2 into P by 1 plus 2 means Q plus 2P by 3. This is the position vector of P. And also given R is a point not on the line PQ, and F divides or otherwise, and QF what they given, then they only we can write QF is to FR is equals to 2 is to 1. Also given R is a point not on the line PQ and QF is to FR is equals to 2 is to 1. That means F divides QR in the ratio 2 is to 1. So by using this ratio and the position vectors, we can find the position vector of F. That is F divides QR in the ratio 2 is to 1. In the ratio 2 is to 1. Then position vector. Then OF, position vector of S is equals to what? 1 into position vector of Q plus 2 into position vector of R. 1 into Q plus 2 into R by 1 plus 2. So that implies Q plus 2R by 3. So here we get OE and OF. See, once again I will explain. The given PQ is a segment which is divided by E internal in the ratio 1 is to 2. 1 is to 2. So let us assume as O as the origin, when position vector of P is equals to P, position vector of Q is equals to Q, and position vector of R is equals to R. When E divides PQ in the ratio 1 is to 2, it is nothing but M is to N, then the position vector of E will become MB plus NA by M plus N. 1 into Q plus 2 into P by 1 plus 3. So we get the position vector of E. And also the given R is a point not on the line PQ and QF is to FR is equals to 2 is to 1. That means QF by FR is equals to 2 by 1. QF by FR is equals to 2 by 1. QF by FR is equals to 2 by 1. So similarly here also we get F, position vector of F by using the section formula, which is nothing but Q plus 2R by 3. So now the problem is we have to prove what? EF is parallel to PR. EF is parallel to PR. So first of all, find EF. EF. Now EF is equals to what? Position vector of F minus position vector of E. OF minus OE. OF is what? Q plus 2R by 3. Q plus 2R by 3 minus of OE is what? Q plus 2P by 3. Q plus 2P by 3. Q plus 2P by 3. So that implies Q by 3 minus Q by 3 becomes cancelled. When we multiply minus, total will becomes minus Q by 3 minus 2P by 3. So plus Q by 3 minus Q by 3 will get cancelled. When we separate the denominator, plus Q by 3 minus Q by 3 will get cancelled. What will remain? 2R by 3 minus 2P by 3. So EF is equal to 2R by 3 minus 2P by 3. Here we can take common. What we can take common? 2 by 3. Means 2 by 3 into R 2 by 3 into r minus p, where r is the position vector of r and p is the position vector of p. Means r is or, p is op. So EF is equals to 2 by 3 into OR minus OP. OR minus OP is nothing but what? PR. Because if EF is equals to OF minus OE. So similarly, OF minus OE is equals to what? EF. So here also, OR minus OP will become what? PR. Means EF is equals to 2 by 3 PR. 2 by 3 PR. What we get here? One vector means EF vector is the scalar multiple of another vector. If one vector is the scalar multiple of another, then those two are collinear or those two are parallel. Those two are parallel. So therefore EF is parallel to PR because EF is the scalar multiple of PR. Scalar multiple of PR. So once again I will explain this. So this they give the PQ segment and E divides PQ in the ratio 1:2. So let O be the origin, then this position vector is P, position vector of this is Q, position vector of this is R. So by using these position vectors and this ratio, we can find the position vector of E by using section formula. And also the given R is another point which is not on PQ, and F is a point which divides QR in the ratio 1:2. Indirectly it is given that 2F is to FR means F divides QR in the ratio 2:1. 2:1. So same similarly here we get the position vector of E. Similarly here also we get the position vector of F. Then after we have to prove what EF parallel to PR. So first of all to find EF. EF is equals to position vector of F minus position vector of E. Substitute those position vectors, we get the vector EF as what? 2 by 3 R minus P. Where R is the position vector of R or minus P is position vector of P is OP. OR minus OP is nothing but PR. So here we get EF is equals to 2 by 3 PR means EF vector is the scalar multiple of PR vector. That means those two are collinear or those two are parallel vectors. Those two are parallel vectors. That's it. So in this exercise, in the last bit, third one is as homework. The first exercise, third bit, third problem. Now the next vector equations of line. Vector equations of line and also plane also. After line we can find vector equation of plane. So vector equations of line. The first theorem is the vector equation of the straight line passing through the point A of A and parallel to and parallel to B. Here we have to find a straight line. We have to find a straight line equation. The straight line is passing through this and parallel to this vector. passing through this and parallel to this vector. So then the straight line equation will become what? R is equals to A plus TB. A plus TB, where T is any real number. Where T is any real number. See the proof. We given a vector. Here A of A means A is a vector with the position vector as A. A of A means here small a is the position vector of this vector. Small a is the position vector of this vector. This meaning is small a is position vector of this vector. So now we give a vector A whose position vector is A. And this is parallel. Whatever the straight line we have to find, that straight line is passing through A and parallel to another vector B. The required straight line is passing through A and parallel to the vector B. So let O be origin. Let us assume O be the origin. Then the position vector of A is the given. Position vector is A. We given that. Let us assume P be any point on this. P be any point on the required straight line with the position vector R. P be any straight line on the required. P be any point on the required straight line. Let O be the origin. And P of R means the point with the position vector R. P of R be any point on the line. So see clearly AP, the vector AP is parallel to the vector B, right? The vector AP is clearly parallel to B. That means one can be written as the scalar multiple of other. So clearly AP is parallel to B. So we can write one vector as the scalar multiple of other vector, where this is any scalar or any real number. Scalar means any real number. So AP is parallel to B means one vector can be written as scalar multiple of other. Here we can indicate scalar with T or lambda or another S, whatever. With your initial also, we can indicate this. So there is no necessary to indicate with lambda only. So we can indicate with any alphabet here. So AP is parallel to B. So AP can be written as the scalar multiple of B. AP is nothing but what? OP minus OA is equals to TB. The T belongs to R. This is must and should. T belongs to R is necessary. So that implies OP is equals to what? When we transfer OA to this side, we get positive OA plus TB. That implies OP is nothing but position vector of P, which is R. OA is nothing but position vector of A, which is A, plus TB. T belongs to R. This is if and only if condition. We can do this in if and only if condition. So they give a line which is passing through A and parallel to B. We have to find a straight line in the vector form. So let us assume a point P on this straight line. Then OAP is parallel to B. That means one can be written as the scalar multiple of other. So by this we get the vector equation of the straight line which is passing through A. So in this formula, vector equation of the straight line which is passing through A and parallel to B. Then the equation will become R is equal to A plus TB. Here A is the point on the straight line and B which is scalar multiple and B is the vector parallel to the reverse vector. So let's see if they given a this like this. If A is equal to I plus 2J plus 3K be a vector a vector on the straight line. And B is equal to I plus 5j is a vector. Then find vector equation of the straight line passing through A and parallel to B. If the question is just like this, to give a vector A and B, we have to find a straight line which is passing through A and parallel to B. Then simply equation will become what? A plus CB, that is belongs to R. A plus CB, that is belongs to R. A is nothing but what? R is equal to A is I plus 2j plus 3j plus 3 into the vector B is nothing but the vector which is parallel to the straight line. What? I plus 5j, which is nothing but R is equal to, here the coefficient is 1 and here the coefficient is P. 1 plus Pi, 2 plus 5. So the homework is in the next second exercise, first bit, first one. Do the exercise problem, first bit, first one, and also in the previous exercise, third bit, third one. Those two are the problems. Yes. Thank you,
madam.
Yes, sir.
Thank you, ma'am.